So in this video, continuing with binomial probability, I'll be working through 3 worded problems that are reminiscent of ones you could expect in either textbooks or in exam style questions. I'll be going through, talking you through what you should be thinking, general sort of methodology and key things to make your work a little bit efficient, and also going through what you need to include in your answers. So what we're going to do is going to go through 3 worded typical questions that you could get asked in an exam. So in this first question it says that 30% of pupils in a school travel to school by bus. From a sample of 10 pupils chosen at random, find the probability that A, only 3 travel by bus, and B, less than half travel by bus. So the first thing we want to do when we're starting with these questions is first of all identify the parameters. So the first thing I'm going to do with this question, even just before even starting, is I'm just going to write number 1. I'm going to write down that X is binomially distributed with a sample size of 10 and a probability of a success of someone travelling by bus in this particular situation is 0.3. And that would probably in an exam be worth 1 mark, so I always state that. Now, one key word that you need to look out for is independent. Now, obviously looking at the 4 criteria that make a binomial model, it might not be obvious, but in exam situations you kind of just assume that you're going to get asked a binomial distribution question, so you kind of assume that all 4 of those sort of sections are ticked. So going to this particular question, the question I'm actually need to work out is the probability that X equals 3. So for this, what I'm going to do is first of all find out how many combinations of 3 out of 10 there are. So I need to use the NCR function on my calculator. Then it's the probability of a success, which is 0.3, how many successes I want, which is 3, times the probability of a failure, which is 0.7, and the number of failures I want out of 10, which is going to be 7. And if I type that all into my calculator, I get an answer of 0.267 to 3 sig fig, like so. So now dealing with B, so again I'll use a different colour for this one. So for B, it's asking for less than half travel by bus. So less than half is basically the probability that X is going to be less or equal to 4. Because if half is 5, I want less than half, so it's going to be 4. So what I need to work out for this is the probability that X equals 4 plus the probability that X equals 3 plus the probability that X equals 2 plus the probability that X equals 1, and finally the one that a lot of students tend to forget is X equals 0. So what I'm going to do is I'm actually going to work out what each of these probabilities are, and again I'm going to show you my full working out. So here I've got 10, not over 4 because it's not a fraction, over 4 times 0.3 to the power of 4 times 0.7 to the power of 6, and I'm going to work that out. 10 3 times 0.3 cubed times 0.7 to the power of 7. 10 times 0.3 cubed times 0.7, and I don't know why I put a cube there, that should be a square. Now, just talking while I'm completing this all together is, can you get this a really long question in an exam? Well, yes you can. Is one aspect. However, you might find that numbers will be a little bit easier to work with, but it's generally the methodology that you're looking for. Now later I will show you how you can use your calculator to answer these types of questions in particular a lot quicker. But in order for you to understand what your calculator is actually doing, it's important that you do learn this more long-winded way of working these problems out, because if your calculator fails, or it's always good to know actually, particularly at a high level of mathematics, particularly A level, and you're wanting to achieve those higher grades, is understanding what it is your calculator actually is doing and what formulas are programmed to do such things that your calculator does do. And this is basically what your calculator could do. So if I work out each of these individual probabilities, now common question I often get asked is a rounding. Now when it comes to rounding, really the rule of thumb is that you should only really round your final answer up, and never round up in between in terms of your working out. So personally what I would recommend that you do is, now if we're going to give our answers to 3 sig fig, then basically what I would say is go up to 5 sig fig whenever you're writing any working down values. Now all I'm doing now is just writing down the actual answers to this particular question of each particular one as what my calculator would show. So I've got 0.266827932 and 10 to 2, keep calling it 10 to 2, 2, 3, 3, 4, 7, 4, 4, 4, 0, 5, 0, 1, 2, 1, 0, 6, 0, 8, 2, 1, and finally 0.02824752449. So now what I need to do is add up all of those probabilities, and if I add up all those probabilities I get the accurate answer, and rounding up to 3 sig fig I get 0.850, and there we go. Now again, if you were to, obviously you don't need to round up all your answers, just go up to a couple significant figures more. That shouldn't really affect your final answer. Your alternative is, rather than working these out, is basically using your answer function on your calculator, or you could, depending on how much time you've got and how much accuracy in terms of confidence you've got in using your calculator, you could enter those as its accurate value and then just simply add them on as you go along. But it's entirely up to you. But the correct answer you should have is 0.85. And like I said, when it comes to these particular questions, it's always worth highlighting where your answer is, particularly if your work is all over the place. But generally speaking, in an exam, this question could easily be worth, particularly section B, could easily be worth about 3-4 marks, in which we probably do this in about 3-4 minutes. So moving on to the next question. So here we've got in a survey, let me just move that slightly up. So in a survey on washing powder, it is found that the probability that a shopper chooses soapy suds is 0.25. Find the probability that that is a random sample of 9 shoppers, that A, exactly 3 choose soapy suds and B is more than 7 choose soapy suds. So in terms of A, so again let's do that in purple. So again I'm going to start off by first identifying my parameters. So here I've got a sample of 9, like so, and I've got 0.25. And if you just bear with me, it's kind of annoying me that this question does not make any sense. So we'll just correct that now. There we go. And we'll continue. So here, from this, the question is asking us for exactly 3. So just like before, I'm working out the probability that x equals 3. So again, I want to work out how many combinations of 3 out of 9 I can get. So I'm going to do 9, 3 using my NCR function on calculator. I'm going to do 0.25 with probability of success to the power of how many successes I want, which in this case is 3, times the probability of a failure and how many failures I want. And if I type that all into my calculator, I get an answer of 0.234 to 3 sig fig. And then for B, so again let's choose a different colour. Now for more than 7, so again it's out of 9, so more than 7 is basically looking at the probability that x equals 8 plus the probability that x equals 9, and these are the 2 probabilities that I then need to go on to find. So first of all, let's work out what 8 is. So again, 0.25 to the power of 8 times 0.75 to the power of 1, and if I type that into my calculator, it actually gives me a fraction, which in some cases is going to be a little bit easier. So 262.144, and then I work out the probability of getting 9 successes. So all 9 choose soapy suds. So it's going to be 0.25 to the power of 9 times 0.75 to the power of 0. And again, when you got to the power of 0, that's automatically going to equal 1, but I still would type it in your calculator just to make sure you're doing it right. And we get an answer of 1 over 262.144. So now what I need to do is add these 2 fractions together, which by doing it as a fraction makes it a lot easier. So I've got 28 over 262.144, which I know is going to simplify to give me 7 over 65536, which gives me an answer of 0.000107 to 3SF. And there's my final answer. So moving on to our last example. So here example 3. So reading the question out hopefully is written correctly. So the probability that it will rain on any given day in September is 0.3. Stating any assumption made, calculate the probability that in a given week in September it will rain on, and then A is exactly 2 days, B is at least 2 days, C is at most 2 days, and D is exactly 3 days that are consecutive. So this one's a little bit more complicated, and you just need to take an extra time in how you're reading the question. So the first thing I need to state is, well, stating any assumption. So whenever you get asked this, and again, excuse the pun on this, but 9 out of 10 times, the assumption is always going to be, so if I just write down here, the assumption is that it's going to be independent. So in other words, that the chance of it raining on one day is has no impact on the probability of it raining the next day. Now you might think, depending on what country you are, is that if it rains on Monday, then there's a good chance it might rain on Tuesday. So you might think, well, let's have a look at the previous weather, and there you go. So the assumption that we kind of need to make is that the weather is independent on each day. So if the probability on any day in September, which is why it says any day in September, is 0.3. So there is our assumption. Now, it doesn't say in any part of A, B, C, and D whether we need to make that assumption, but it does say, so I definitely would write that somewhere in your answer and start off by writing the assumption is that it is independent. So once we've done that, what we then want to do is set the parameter. So here, our probability now here, it says in a given week. So although it mentions a month, you might think, oh, it's 30 days, definitely, but you just need to be careful with when reading the question. So here, our sample size is 7, and the probability of success in this case, well, if it been raining, I don't know whether you can class that as being a success on a rainy day, is 0.3. So for A, what we need to do is the probability that x equals 2. So again, I'm going to go for, I'm just going to just save a bit of space on this one. So I've got 7/2 times 0.3 to the power of 2 times 0.7 to the power of 5. And if I type that into my calculator, I get an answer of 0.318 to 3 sig fig. Done. Now for B, let's do another colour. Now at least 2 days. Now at least 2 days is basically including 2, 3, 4, 5, 6 and 7. So I've got to work out each of those 6 potential probabilities and add them all together to get the answer to B. Now an alternative to working out each of these, finding those 6 probabilities and adding them all together, is to work out what I don't want. So what I don't want is 1 and 2. So if I just write or 1 minus the probability of it being 0 and 1. So what I'm going to do is either working out 6 probabilities or 2 probabilities and take it away from 1. The latter is definitely the option I'm going to go for. So here the probability that x is greater or equal to 2 is the same as 1 take away the probability that x is less or equal to 1. So first of all, working out what the probability of 1 is, and that's going to be 7, 1 times 0.3 to the power of 1 times 0.7 to the power of 6. And if I type that into my calculator, I get 0.2470629, and then work out the probability of that x equals 0. So that's going to be 70 times 0.30 times 7 to the power of 7, and that gives me an answer of 0.0823543. And then I can work out what the probability of x is less or equal to 1 by adding those 2 probabilities together, in which I get 0.3294172. So therefore the probability that x is greater or equal to 2 is going to be 1 minus 0.3294172, and that gives me a final answer of 0.6705828, and rounded up gives me 0.671 to 3 significant figures. And there we go. Now for C, and again I'll do a different colour for C. So for this one we're looking at most 2. So most 2 is basically including x equals 0, x equals 1 and x equals 2. Now for this I've already kind of worked out what most of them are, so the only thing I've then got to work out is the one that's missing, which is x equals 2. So for this, if I just quickly work that one out, so here we've got for C the probability that x is less or equal to 2 is equal to the probability that x equals 0 plus the probability that x equals 1 plus the probability that x equals 2. And if I work out each of those, and I'm going to save a bit of time, I'm going to just do in advance. So here I've got 0.0823543 plus 0.247069. And if I actually look at it, I've actually worked out what each of those three probabilities are. So I'm using this one, and if I just highlight it, so I'm using the answer from A and the two answers from B, and I've got 0.318, and if I add all of those up I get a final answer of 0.647069, which gives me an answer of 0.647, which is 3SF. Done. Now for D, now this one's a little bit more complicated, so what I'm going to do is I'll just quickly create a bit of space. So sometimes you might find that a question might take you a while, and it's just a case of spotting and being a bit smart. And I would say that the more questions you attempt, the shortcuts you will find, and you'll find that with practice you will get quicker. Initially it always takes you ages doing these questions, but I promise you with time you will become a bit more efficient and you'll become more accurate when you're using your calculator. And like I said, in the next video I'll show you how you can use your calculator to hopefully make you a little bit more efficient. So working with question D, now for this one's a little bit more complicated because of the contents of the question. So here we're looking for exactly 3 days that are consecutive in a week. So what I need to do first is find out how many different combinations I can have with 3 consecutive. So here I've got, so that's 1, 2, 3, 4, 5. So it's 5 different combinations that I can have. So it's going to be 5. So that's the NCR function bit done. Times. Now out of these 5 days I want 3 of them being rainy, so that's 0.3 to the power of 3 times the probability of it not raining, and I want 4 of those. And if I type that into my calculator, all I then need to do is get the final answer, which is 0.0324, and that's the answer to 3 sig fig. So sometimes you can use your calculator, and your calculator can be a brilliant friend when you're doing these questions, but don't forget to use common sense. And if you're not too sure, try and go back to old school methods of writing down your combinations. But like I said, there is no need to write down every single possible combination. It's just being a little bit smart when you're working through these questions. So hopefully these just gives you a bit of an insight, and when you're working through questions either in a textbook or an exam, hopefully you can relate the question that you're doing to one of the 3 examples or from the previous video to try and make some sense. But like I said, the key thing where a lot of students tend to go wrong is that they never really start a question off by writing the parameters down, which is always a good point. And again, if you get asked any questions of any assumptions that you made, it's generally always going to be the fact that each event is independent, because they always seem to miss that word off when they're wording these questions.